Hi, my name is Jason Chanko, and I'm an applications engineer at SIGLENT Technologies America. And today I have an interesting video using a function generator and an oscilloscope to characterize a filter. So I received a call from a customer a few days ago that wanted to characterize a bandpass filter, and all he had available to him was an arbitrary waveform generator and a scope. So I decided that would be a pretty interesting application. I'm also going to compare that measurement with a tracking generator and a spectrum analyzer a little bit later on. So we have our RF filter. Again, this one runs from 1.8 to 30 megahertz. And so I selected an SDG2000, the 2122X. So I want to perform a sweep with this particular instrument. And you'll see it's a linear sweep running from 1 megahertz to 50 megahertz in 100 milliseconds. It's a 50 ohm output for the load because the device under test is for RF. It's also a 50 ohm output. You can see here it says 52. And let's see, 2 volts peak to peak. So 2 volts peak to peak is just the test values that I'm using. That's going to be a 1 volt positive peak and a minus 1 volt negative peak on that sweep. So connecting through that adapter here and out through this adapter over to our oscilloscope channel 1. And so in this particular case I'm using an SSA3032X and I am triggering. You'll see these are each successive sweep, and you'll see that once we get to a certain frequency we get a fairly nice roll off here. And what I did, since we are running 1 volt peak to peak, or 2 volts peak to peak, I'm sorry, 2 volts peak to peak here, we're going to have a 1 volt max peak here. So I just set one of the cursors to 1 volt, and the other, since we wanted to take a look for the 3 dB roll off, I just set the second cursor to 700 millivolts. It's actually 707 would be the 3 dB point for 1 volt, but very, very close to get us in the ballpark. And you'll see that the two triggers here, we've got 1 volt and we've got the 707. In this particular case, triggering on these can be a little bit tricky. So what I had done was I used the interval trigger. The interval trigger, if we just press, will give us a little bit of help information. Basically, we're just looking for a time delay. And so I just set the time delay range to about 26 nanoseconds, and I get a nice stable trigger. Again, we are triggering stably here. And what you can do now, I tend to put the instrument into single mode once I've captured it. So basically, we set channel 1 to the maximum VPP level. Then we want to go 3 dB below that point and then align this trigger location. It's going to zoom around the center, so we can't really see much as far as the frequency here. But now what I will do is zoom in on that area. Again, I should let you know, acquire, so pressing the acquire key here is going to give us access to the deeper memory, so we want to set it to the maximum memory depth. Because we're dealing with a 50 ohm system with this oscilloscope, we also want to set the input impedance for that channel to 50 ohms. Again, I got there through the channel 1 button. And now I'll just continue to expand. There are a few different ways of doing this, but just bear with me here. Go to single mode, and now we expand it down, and you'll see we're about online with that value here, with this 700 millivolts, and we have automatic measurements, and our frequency is around 39 megahertz. So the 3 dB point for this filter, again using this particular test setup, provides a very nice and easy way of measuring that 3 dB point, and we're looking at 39 megahertz. So now let's compare that to a more standard way of measuring it, which would be using a spectrum analyzer with a tracking generator. Alright, now let's take a look at the same filter, and we're going to use a spectrum analyzer with a tracking generator. Very briefly, the tracking generator located here is an RF source that is going to sweep from the start frequency to the stop frequency in line with the detector for the measurement side of the spectrum analyzer. So basically it's an RF source that's sweeping at the same point as the detector, and this RF energy is then going to be delivered to our filter, and at a particular frequency we expect that to start to cut off and the filter starting to absorb that particular frequency range as we go up. Again, this is a low pass filter, so we should expect to see high amplitude on this side, and then as it gets to the roll off we should see it drop off. So what I have done, since this is a 30 megahertz filter, I've set my frequency. So our start frequency is 1 meg, stop frequency is 50 megahertz. We're going to set up the tracking generator here, So I'm going to turn on the tracking generator, and first step is going to be normalizing. So you'll see I have two adapters as well and two cables here, two BNC cables, and I've got a BNC barrel. The BNC barrel we're going to be able to calibrate. So normalizing, we're going to be able to remove the reflection and absorption effects of the cabling by doing the normalization process. So just 1 second, I'm going to put this barrel in and be right back. Okay, now we're back. I have put the barrel adapter in, and now I'm going to turn on the tracking generator. Oh, so we've got the tracking generator on, and now I'm going to press normalize and turn the normalize trace on, and now you'll see that the line has gone flat and we are at 0 dB. And now I can take out the barrel, just take a second, try to do that one-handed, and connect that to the filter. So here we've got it connected to the input of the filter, and now we'll connect to the output. Aha! Alright, so now we've got very nice trace, very nice and flat, and now you'll see that the filter is starting to roll off. So above this particular frequency we're starting to lose amplitude, and so I can go over here to the marker function. Marker is going to provide us with a frequency and the power readout at that particular point, and so we can just adjust the marker position. And so if we want to find a 3 dB point, that's going to be around 40 megahertz. So we're getting very similar readings using the spectrum analyzer and tracking generator. The advantage of using a tracking generator with a spectrum analyzer, the measurement capabilities of a spectrum analyzer are significantly better, have much lower noise floor and higher sensitivity on a spectrum analyzer than with an oscilloscope. But to do basic measurements on a filter, be able to characterize it, or you have an unknown filter, you'd be able to get in the ballpark, so to speak, with using the oscilloscope and arbitrary waveform generator. So it costs a little bit less. It does have less capability, but to get in the ballpark, it will get you there. But again, if you wanted to get a higher degree of accuracy as well as more sensitivity, a spectrum analyzer with a tracking generator will be the way to go. Well, thank you again for watching this video. If you have any questions, please contact your SIGLENT office. Thanks again, and have a great day.